Hey everybody, my name's Dawn Wages, she, her. I came from Philadelphia and I brought way too many sweaters in my suitcase getting here. I forgot how nice it was in San Diego. I don't know how I forgot that. So really happy to be here. This is also my first JupyterCon. So, who am I? This is my, let me go back real quick. If you want to follow along, this is the QR code for the slides and also on the bottom of most of the slides. I do have the URL, but this is the only time I share the QR code if you want to skip that. And yeah, we're doing the life cycle of a Jupyter notebook. You start from exploration, and we're going to talk about all the way to production grade pipelines in about 25 minutes. So, who am I? This is my why should you listen to me slide. You don't have to. The TLDR is that I volunteer in the community a lot. And you may have seen me around the Python Software Foundation. For about 3 years, I was in some leadership positions, treasurer and chair of the Python Software Foundation Board of Directors. I have recently left at the end of my tenure. It was ceremoniously, it was fine. I love the group. You'll still see me hanging around a lot, but if you are interested in the Python Software Foundation, getting involved, what do they do, membership, please find me. I can talk your ear off or I'll listen to you ask questions. I am the Director of Community and Developer Relations at Anaconda, and it's a relatively new job for me. So the second to last bullet, currently writing domain-driven Django. It's a little more work than writing right now, but if you're interested in Django and domain-driven design and the marriage of the two, you may see me blogging a little bit more. And that's a really good segue into what I've been doing for the past 11 plus years of my technical career. I've mostly been a software engineer. I've also been a technical program manager and a project manager and a consultant, a freelance consultant. So I love to get my hands dirty. I love to jump in and before I know what's going on. And so I'm hopefully bringing back some things that I've learned in my software career that can apply to your data pipelines, deploying your Jupyter notebooks. And specifically, we have a few slides on modular code and architecture that I think might be helpful in machine learning scenarios. Oh, I'm also a co-host of the Sad Python Girls Club podcast. So if you are interested in that, we are on hiatus, but we're coming back. And we're not so sad on the podcast, but we're sad in spirit, so join us. If you want to see me on Anaconda channels, we are starting up live streaming, so you can join the Anaconda live stream. This is Anaconda YouTube, and we're posting on there more often. We have these cute little things called the Python Tips Tuesdays, and you'll see a whole bunch of faces of Anacondiacs on that all the time. And in my capacity as Anaconda DevRel and as somewhat, I don't know, someone who can't keep their hands still in the Python Software Foundation community, I have, along with my colleagues, have taken a stab at helping with the Python packaging ecosystem. If you're not familiar with that, there is a hubbub or there's a decision across the ecosystem that we need we need better standards across Python packaging, and it's something that a group of people have come together to solve. There is a Python packaging council now that is now through from a PEP, things like that. And this is the Python packaging ecosystem survey. It is sponsored by Anaconda, but it was written with the help of 30 plus friends in the ecosystem. That includes Microsoft, Google, Wheelnext, Gentoo, Astral's in there. It's about 30 questions and it takes about 10 to 15 minutes on average, and we have over 19,000 respondents. All of the data will be public in Q1 of 2026, and then we'll do the whole thing over again, launching in May and closing in December again. And so if you want your data or your interest, it's no data, but it's just your thoughts about your packaging user behavior in this survey, this is a QR code. Please take it. It's how we can build better tools for you. All right, so what are we covering today? 5 steps. 5 steps is all it takes. It gets deeper in there, but 5 steps from going from an idea all the way to your production pipeline. We start with setting objectives. We'll talk about modular code, choosing your tool, reproducible environments, and then deploying resilient projects. So I'm a project manager at heart. I always will be, even as I'm writing code or in other domains. And so in a lot of my presentations, I commonly ask, well, are you talking about it first? Because the first way to unblock yourself on a lot of your problems is setting the domain scope and understanding the domain problem. I've done this many, many times before, and as I'm getting my head around the task, I'll start writing a proof of concept first and then have the conversation about the scope after I've had a half a day tinkering. If you're building in feedback loops and you're comfortable pivoting, this isn't so much of a loss. But what you end up doing when you're bringing up that conversation with your peers is they're starting from greenfield and you're already starting from a proof of concept in front of you. And so now you're iterating while your stakeholders are open-minded. And that means that you're starting from two different places. So some tips on setting objectives with your team. I love a kickoff meeting. There's also nothing wrong with saying, I don't know. So when you face concerns directly, you're able to gather all of these considerations. And then I love starting from the very beginning, starting communication protocols. RACI for people who may be familiar are responsible, accountable, considered, and informed. That's a process that you can use to make sure that everyone is in the loop to the degree that they want to or should be in the loop. It's also kind of a way of having an escalation path or a framework for decision making on the fly. Frequent check-ins, progress reviews. Some of this sounds really obvious, but just putting it on a slide and remembering, oh, check, 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 check. I did all the things. We could start the project. The more public, the better. The more eyes on the doc, the more feedback, the better the product. And then we're actually in the objective setting. A few points that are really important to me as I'm starting a new project. And some of these things, as you get practice on them, they're perfunctory. Be careful between your outcomes and your outputs and do not conflate the two. They are both very important, but outcomes are the changes or impacts you want to achieve, but outputs are the tangible products if you're doing data sets, publications, presentations. You'll want to build in the flexibility as you go. So those frequent feedback loops when you're setting those clear objectives, and then do yourself a favor and give yourself milestones. Even if you are far off of these time-bound milestones, it is a data point that you are missing your milestone, and you should think about rescoping. It is important that we release shame in programming and missing our deadlines. It is okay. It is one of the hardest, second to naming variables, assessing deadlines and timescales for programming is the second hardest thing to do. It is okay, but it's still important to set time-bound deadlines. And then why does this matter? This is the last slide, but I just really want to underscore a point on how it actually improves the code that you output starting with communication. Your domain language will flow throughout the fabric of your entire project. That kickoff call where you are assessing the information from the experts, they will show up in your features, in your parameters. These are early conversations, and they can spin out into diagrams that are easily digestible and then also able to be iterated through to non-technical stakeholders. And you're able to evaluate the effects of these artifacts of the life cycle of your Jupyter notebook. So you are now putting, with all of these artifacts, a flag in the ground from where you started, and then you are able to assess as you continue to do that iterative feedback loop on how far you are getting and then how far you might be drifting. And sometimes that's a good point. We have made a concerted effort to move away from where we started, and then you are able to kind of justify some of that input and effort. So again, I am always a project manager at heart, and so these are some of my tips of the trade that I recommend people follow when you are building without a PM. Next, we'll talk about modular notebooks. This is my favorite part. I am a software engineer, and one of the things that I love to bring to the iteration of my data science workflows and when I get a project that is big enough is modularizing, making modular code. So if you're doing it after the fact, the actual answer to the question on how to make modular code, you'll want to identify your reusable chunks, you'll extract functions with clear inputs and outputs, move functions into your .py files, import and use a clean notebook, and then you'll add tests. But what does that necessarily mean, and what are some patterns that you might see arise as you are building the components of a maintainable, testable, and scalable notebook? This will remove the urge to have some of the stinky, smelly spaghetti code that's difficult to run in order. Or if you find yourself copying over code from one notebook to another, you are in a tough spot. You should make your code more modular. So there's 3 slides, there are like 5 kind of disciplines. So first one I want to talk about is ETL and feature engineering. So ETL, for people who may not be familiar, is extraction, transform, load, and it's from going from the data store sources to your data store. Transformation will be highly dependent upon your scenario, but here are some of the bullets, and I'm not going to read specifically to the slide, but for ML scenarios, transformations can include some feature engineering. For those who are, to get a little bit deeper into it, so that's when you're transforming some of the raw data into features or your input variables in your machine learning workflow, and it'll better represent the underlying problem in your model, ultimately improving your performance. In green, I have methods. In yellow, I have classes. These are a few of the next slides may scratch an itch for you if you are like interested in this. I recommend you read the book Designing Data Intensive Applications. It's honestly, I just keep it next to me all the time. It's like a nighttime reading for me. I love it. I mean, it's not very intimidating of a book. It's like this big, and it's printed by O'Reilly. I should shout out the author, but I'm blanking on their names. I also recommend looking into software architecture design patterns in Python. A few are shown, but my favorite things ever that I've ever built was a Python rule engine. So it really kind of scratches the itch on having flexible modular code. So here's a builder pattern. Someone in the back, can you nod if you can read this? Yeah, it's okay? Yeah? Okay, cool. So what we're doing is we're defining a class and then also adding methods where you can add steps, and then you are able to use it where you are actually adding those steps with the different additional methods, and then you have the final method where you can execute all of the steps sequentially. So this is in my etl.py file, and when I initialize this object, it starts with steps as an empty list. You can see at the bottom, we're defining steps, and then these snippets like this can be helpful in guiding you towards a project that scales more effectively. You're able to identify problem code better with these patterns, and at least to me, this brings more joy in my developer experience. This is my home. I love this when I can break it up and make it real pretty. Another one that I wanted to shout out, these are specifically methods modules brought in from scikit-learn base. This is an example of a class that you can have a base estimator and a transformer mix-in. These are 2 patterns brought in directly from scikit-learn. I did not build them. I'm not an expert on the entire ecosystem, but what I do recommend is looking into specifically scikit-learn base, but also other helper modules that will guide you into having more modularized code and can help with the division of responsibility, make your problematic code more easy to find, and have a better and more enjoyable developer experience. Next, we're talking about training and evaluation. Again, the methods are in green and the classes, and these are all examples just to kind of jog your or give you some ideas on how to separate your code and what you can actually build from them. So for example, you could have a modeling file, and I can import my model trainer, I can import my model evaluator or a cross-validator, hyperparameter tuner or experiment tracker. All could be classes that you can abstract away some of the complexity and then have very easily accessible the fields that will make decisions. It can switch based on how you'd like your code to perform. Yeah, cool, that's enough. And then last but not least, this is a little bit of a hand wavy slide, and I fully acknowledge that. What you're going to want to do when you're deploying your Jupyter notebooks or your Jupyter Hub, which is more common, can vastly, vastly differ. What I really recommend, a lot of the cloud service providers, specifically the hyperscalers, will like a Google, Azure, AWS. They will have opportunities for you to upload an IPython notebook, or you can use their embedded notebook, and you will have compute there. And then some of them, and my favorite features, will have a way to share those notebooks persistently. Another tool that I really like is code spaces on GitHub. So if you press that green button, you can open up a cloud notebook and you can pick your compute, and for now it's free. I don't know what Microsoft is going to do with it, but it is an easy way to explore and play in your notebook, to have and then share that persistently with your code and your version control all next to each other. That's not necessarily any type of production pipeline, but it does add for collaboration and shareability features in your toolchain, which is a lot of times what we're solving for when we want to put a notebook in production. This is a link to this is the Jupyter.org docs. It's nothing special. And then underneath that is a link to Jupyter Hub docs where there's a bunch of examples of Jupyter Hub deployed. And then we'll also talk about like utilities. These are another example of utilities. All are methods, and these are things that you're going to reuse across your code and may show up in other objects or other processes. And this will result in somewhat of a light notebook experience. So a common directory pattern is having your notebooks at the top, and then having very little in them. So when you want to go searching for the very well-named tool, you'll be able to go into your source code and then click around and find the module. Again, separation of concerns makes it easier for you to find and deploy. So next, let's talk about choosing the right tools. The old school approach was using one monolithic architecture for an on-prem database, and then the rest you're building yourself with SQL, cron jobs, shell scripts, and you had to do it all on Windows. Now we have flexible architectures, drag and drop UI pipeline creation, and exotic hardware options. And the majority of deploys are happening on Linux distributions. Another thing that I have in like a lot of my presentations, this is just a bit of an anecdote. I give these talks a lot, and one of my favorite things to talk about is the evolution of the Python ecosystem in scientific computing as it started in the 1990s all the way to today. And so what we saw prior to that was a scientific distributions that were really expensive, and you had to sell seats to the entire institution. And to be able to free ourselves from that with the rise of Python, a lot of researchers, data scientists, use this really accessible language, one that you can almost read verbally as you're looking for what's going on. And they started building tools for themselves for free in the open. After that, we evolved into, and I think that was probably maybe like the second wave of scientific computing. Now we're in this really interesting wave of like rapid innovation. There's a huge focus on increased developer experience. For example, if you're interested in product managers, people have, the ecosystem has spoken and aligned on project-centric package managers. So Pixie, UV, Poetry, all kind of aligned to that project focus package manager experience. And then a lot of these really nice tools that are getting faster and faster are developed by tech companies, Netflix and Meta, and or are supported, or in NVIDIA, or are supported by open source or open core companies like Anaconda. So this is by far not all of the tools that you can use in each of these categories. This is what I'm using and experimenting on these days. Anaconda, Jupyter, Conda, Pixie in this environment management quadrant. How do I manage my dependencies? How do I explore data interactively? For the lifecycle management flow, I've been playing with Papermill and ML flow. Papermill will say, how do I automate this notebook? While ML flow will answer the question, how do I track my experiments? Visualization, I want to do a special shout out to PyScript in the middle. PyScript there's this super cool demo that I saw from some students at Tufts. Shout out to Tufts. And they had Lego robots, and they had the data ingestion from the Lego robots, and then they used PyScript, which is Python, in the browser, and it was all running 100% in the browser. It compiles down to PyDide and WebAssembly, and so you are able to do data visualization, or all of your Python work in the browser, which is really cool. And then last but not least, your cloud and compute. Rapids will talk about how do I make this faster with GPU. That's authored by NVIDIA. NVIDIA, these are GPUs provided by NVIDIA. Amazon Bedrock will surface that, and so I'm using Amazon Bedrock with my GPUs. And then Snowflake I've been using for my production ETL. And so when we're choosing the right tool, Papermill will let you execute Jupyter notebooks with different parameters, like running a Python script with command line arguments. So if you want to turn your notebook into a parameterized workflow, this is what you'll want to use. For example, if you run the same code with different dates, different regions, different customers, or a different data set. So it's easy to install. I highlighted Pixie and Conda, which both use the Conda ecosystem, but you can also use pip. And this will automate your reporting. So these are good tools for common practices like automating your reporting, or batch processing, A/B testing, or structuring client deliverables. And then finally, you'll run through the command line. This is an example of running it through the command line. There's also a shorter command if you want to take your variables and put them in a shell script. For ML flow is going to track your ML experiment, so you never have to lose track of what you're working on. And it also has this UI experience in your browser. So you'll do like, I didn't write the one-liner here, but it's like a ML flow UI or show UI or something like that. And that's a little screenshot of the UI experience. And this is for tracking your projects, so it'll log your parameters, metrics, and artifacts. It'll package your code for reproducibility. It has your models for standardized model format, and then there's a central model store for your with versioning for your registry. And choosing the right tool is really hard, especially as you are in this ecosystem and people are building even specifically plugin and plugin type ecosystems. There is this divergence of where the right tools are. So thanks for listening. I would love a little bit of interaction. How many people use awesome Jupyter or Jupyter Hub to find tool recommendations? What about getting recommendations from your peers? Okay, so that's like probably 70%, maybe like 80. What about first-party documentation recommending third-party tooling? Do you go to Jupyter Hub for your third-party tooling recommendation? A couple of nods. And then what about your AI tooling? Are you going to a chat or an AI and it's recommending what you should use next? So specifically some no's, a couple of yes. So it sounds like there's some AI reticent people in here, but also some people who are adopting it. Smaller number. So it really sounds like relying on your peers is where we're leaning in this audience, and that absolutely checks with my previous questions from other audiences. You are absolutely in the same boat as the rest of the ecosystem. That also leaves gaps for product and tool discovery. So one of the things that I recommend is sharing and being part of the peer recommendation system. Write about your experiences, give talks at conferences, and share in some of that peer advocacy. Uh, Next, we'll talk about reproducible environments. This is my cup of tea. So here, this is like a long page of recommendations on how to have reproducible environments. We'll highlight a few of them, but you'll want to pin the exact version and use lock files. I recommend using Pixie for the Conda ecosystem. Build with virtual environments. Conda is a virtual environment, but you can also have Docker. Docker is a great tool if you're comfortable with that learning curve. There is a tip for Conda specifically. Not a lot of people are familiar with Conda Pack, which is a CLI tool to create archives of Conda environments. You can have data version control, and then I also recommend, this is common practice, but set random seed values to test your code frequently. And these are packages on a pallet for their reference. PyPI has done well in the ecosystem with compiling C, C++, and Rust code with common packages like NumPy, Pandas, or Pillow. These are notoriously really hard because they have packaging binaries, but because they're so widely used, UV specifically, but like the wheel formats that people are publishing will have pre-bundled binaries, and they do fine, but it's not what their PyPI is naturally very good at. It is a Python exclusive environment. Meanwhile, if you're using the Conda ecosystem, it is a language agnostic runtime, so you are able to more easily pull in bundles using imaging libraries, which are really hairy, like Pillow, libjpeg, libpng. Those are really tough. Those handle better in the Conda ecosystem. And if you're using GDAL, HDF5, NetCDF, which are not bundled, or R libraries or Julia packages, Conda will help with that. Also, consider your hardware. So there is a larger push these days. It's also part of the wave of new computing to have GPU-enabled compute. So you'll want to document your GPU and CUDA versions. They're very, very specific with the CUDA and specifically the SciPy version that you're using in your project. So you'll want to document those if the CPU is accessible. And also document if the CPU is acceptable option. Your cloud resources, again, are great for trying out and playing with novel architecture and also allowing for your teammates to play and use that novel architecture. And Rapids, which I've been playing with, and if you're interested in like seeing more Rapids in real life or someone who's learning Rapids, I live stream semi-regularly playing with Rapids, the Rapids framework. It is a no-code change, GPU-enabled tooling, so each of the projects in the Rapids library maps to another tool where you will not have to change your code and you're able to access GPU just like you would have otherwise. And you could see all of, Rapids has a platform page, which is really cool, that show all of the service providers that have NVIDIA GPU-enabled computing environments for you. And then finally on this one, binary dependencies. Pip is a Python-only tool, so it cannot handle binary dependencies, as I referenced in the previous slide. PyPI compatible package managers like UV have gotten better at handling pre-compiled binary wheels like NumPy. UV is an awesome tool. It's incredibly fast, and for what you need it for Python-specific executions, it's what I reached for first too. I came from the web dev environment. I love Pip, I love UV. And as I've been playing more in the scientific computing, geospatial, imaging, and CUDA-enabled compute, it's really been I've been reaching for the Conda ecosystem. And vendored wheels can help with precompiled binaries like BLAS implementation. Vendored wheels is just like a terminology where you are bundle and pre-compiling a whole bunch of things inside your wheel format. It makes it easier and it's fine for using, but if you want to be flexible with architecture but pin your versions and you're not exactly sure how it'll work, or it might skip dependencies and you don't know it's going to break until you start using something else, I would recommend trying out Conda. It's getting faster every day. This is a cool blog post. It's a part 1. I've already gotten like emails and posts on LinkedIn how it's helping people build their CI with Conda environments. Here's a QR code. I hope you check it out. And it's part 1 of a series that's on conda.org. And then last but not least, here's a checklist on deploying resilient pipelines, and what does that include? So specifically in ML, model versioning and registry is pretty typical. You'll want an A/B testing infrastructure, and then gates for your data quality that checks your input quality before feeding it to your models. So if your data looks anomalous, you can use a different distribution or missing features. It won't make predictions. It'll alert your humans. You can have prediction monitoring, so it'll track prediction distributions, confidence scores, and outcomes. And then there's also, in a lot of these production tools, is a shadow mode, where it'll run new models alongside production models without affecting your users. In general, you'll want automated testing, staged rollouts and rollbacks, health checks and monitoring in a different format than it will be for your ML pipelines, but still important. Safely repeatable steps, retry logic, and feature flags. So it'll do something different when you have a feature tagged on or off. Resource limits, rate limiting, load shedding for performance, and then logging, observability, and alerts. And so here's a bit of a summary. This is a new image, but it is a repeat of a lot of the considerations that I was discussing before. So the 5 different kind of components on these things in a different format: task complexity, hardware considerations. You want to have access for experimentation and collaboration, developer tooling, and then your application development if you are building an application in this environment as well. And also some more bullet points on how to identify or different things to be of note in each of these 5 areas. And that's me. Please take the Python packaging survey. This is the QR code for it, and it's been a pleasure to chat with you.